All right, last and finally are parabolas. Parabolas are a little bit in depth, but only because they face 4 different directions. Your standard form of a parabola is found here. A parabola is all points that are the same distance from a fixed line, which is called the directrix. You'll see it here. And a fixed point, which is called the vertex here. All right, there are 2 types of parabolas. You're either going to have one that is horizontally oriented, left and right, or vertically oriented, up and down. Either way, your equations are here. We're introducing a new value, and this value is p. Depending on which side of the equation it is on, it will either be in the numerator or the denominator of a fraction. Notice that I have placed it with the single value, the y value in this case, and the x value in this case. Therefore, it's a whole number value. Another way that you will see it is moved over to the other side of the equation, and you simply move multiplication by using division. Therefore, it would be 1 over 4p. There, it would be in the denominator of the fraction if it's located next to the squared term. Don't be fooled by that when you see it. It is simply a rearrangement using an algebraic process. All right, when sketching a parabola, some things you'll want to know. Go ahead and fill in this information, and the most important thing that you want to realize is the way to find the width of the parabola, or the stretch or compression on the parabola, is by using these reference points. The reference points are going to be 2p units either to the left and right of, or above and below of the focus. So notice in this particular case, since it's a vertically oriented parabola, it'll be to the left and the right of. You'll notice back up here in the example drawings, the reference points are given, and so you can see the difference between the reference points based on the orientation of the parabola there. All right, next we'll move on to the example. The example is the 4th example on your page. So a parabola has a focus of 4, 0 and a directrix at x equals -4. I'm just going to go ahead and sketch this guy here and sketch my vertical line here. Alright, now that I've been given those 2 points, I know that the vertex of this parabola is located halfway between the focus and the directrix at the origin. So the vertex is the origin. The value of p in this case is 4, because the distance from here to here is 4. Likewise, the distance from here to here is 4. I know that the parabola will open towards the focus, so it's going to open towards the right. Now I'm going to go ahead and use those reference points, RP, and remember RP is 2 times the value of p, which is 8. So I'm going to go up 8 units here and down 8 units here. Now I can sketch my parabola using those reference points like that. I want to write the equation of this parabola. Now because it opens to the right, that means it's going to be y squared equals 16. That's 4p times x. Now if you are looking for the 4p to be next to the squared term, it would look like this. X equals 1 over 16 times y squared. Either way is correct, so make sure that you can tell the difference and do not be fooled by which one is where.